Welcome to the deep dive. For I'd say the last 40 years or so, we've all basically agreed on what a computer interface is,
Oh, absolutely.
right? Like you have a screen, you have folders and applications, you open the app to do a very specific task.
You're the one driving it.
Exactly. You open a word processor to write, a spreadsheet to crunch your numbers, a browser to search. The software is fundamentally this static tool, and you are the operator. But looking at the landscape right now, that foundational agreement is it's being entirely rewritten.
It really is. I mean, we are crossing a massive threshold right now. The era where you operate a tool manually, it's basically ending. We're moving into this paradigm where you just state an intent and an underlying system operates a vast array of tools on your behalf.
So it's moving from direct manipulation to delegation.
Exactly. Delegation.
And that brings us to our mission for this deep dive. We are exploring a massive structural shift in the tech world. AI is no longer just this, helpful little chatbot sitting inside your software tools. It is becoming the actual operating system through which all tools are accessed and basically all work is executed. To guide us through this, we're looking at some really fascinating notes from the April 27th, 2026 edition of your weekly AI Pulse by tech leader Manoj Gopalapalli.
Really great source material, by the way.
Yeah, it's fantastic. And his core premise here is that the transition from AI as an interaction layer to an actual execution layer is officially underway. So, okay, let's unpack this, because this shift is changing how engineers build, how non-experts create, and honestly, how C-suite executives strategize entirely.
It's a complete structural shift. And to understand how AI actually executes work now, rather than just generating text, we have to look at the new architecture making it all possible. Gopanapalli points to OpenAI's GPT 5.5 as sort of the ultimate proof point for this.
The big turning point.
Right, because the fundamental shift here is that intelligence is no longer delivered by one single massive model.
Right, which was the old way.
Exactly. Instead, it's delivered through this incredibly complex, layered system that actively balances speed, cost, and reasoning depth in real time.
And this is essentially the death of the model-centric design. Because for the last few years, the entire tech narrative was just a horse race, wasn't it?
Oh, 100%.
Like, who has the biggest model? Who scored the highest on the bar exam?
Right, but running every single user query through a massive, computationally expensive frontier model, it's just incredibly inefficient. It burns capital and introduces terrible latency.
Yeah.
If you ask a frontier model a really simple factual question, the time it takes for that massive neural network to compute the answer.
The latency.
Yeah, the latency is entirely disproportionate to the task. So we are entering the era of orchestration-centric systems. Engineers are basically building these complex routing layers, which is like an invisible traffic controller sitting between you and the AI models.
I was thinking about a good way to picture this, and it feels a lot like a corporate hierarchy to me.
Okay, I like that.
In the early days of these LLMs, you were basically giving every single task in the company directly to the CEO.
Right.
Like, you need a typo fixed, give it to the CEO. You need a 10-year strategic merger plan, hand it to the CEO. It's one incredibly expensive, slow model doing absolutely everything.
And completely burning out in the computing sense.
Exactly. But now, this orchestration layer acts like a really intelligent manager. It instantly looks at your request and evaluates its complexity. If it decides, oh, this is just a quick summarization task, it routes it to the intern.
Which is the fast, cheap, lightweight model.
Right. But if it sees a complex coding problem, it says, we need the senior expert for this, and it routes it to the deep reasoning infrastructure.
What's fascinating here is that the competitive edge for platforms now lies almost entirely in that orchestration quality. It's not about the individual model benchmarks anymore.
It's the routing.
Exactly. The system has like a microsecond to classify the intent of your prompt, predict how much computational power it's going to need, and invisibly hand it off to the right node.
And for you, the listener, the user, this means you get a much faster, more responsive system without sacrificing the depth.
Right. You don't need to manually select which model to use from a drop-down menu anymore.
Yeah.
The system just abstracts all that complex reasoning away, so high-end capabilities just feel like invisible infrastructure.
But building that manager, that routing layer, that has to introduce some intense new technical realities for the engineers behind the scenes. They aren't just training models anymore.
No, not at all.
They're building a massive sorting mechanism.
It is a fundamentally different engineering paradigm.
Yeah.
Because you're having to balance raw model performance with system-level efficiency.
Yeah.
and doing that across millions of concurrent users.
Which sounds impossible.
It's incredibly hard. Let's look at the examples in the source material. OpenAI's Deep Research and Google Gemini Ultra. Deep Research operates on this dual-layer architecture. So imagine you ask it to analyze a decade's worth of financial reports. The orchestration layer first deploys a whole fleet of fast, lightweight summarization models to parse thousands of pages and build an index.
The interns.
Exactly, the interns. Then it dynamically switches to a deep reasoning model to actually synthesize that index and extract the real insights.
So the engineers are constantly playing this massive game of optimization.
Constantly.
They have to manage cost constraints, the latency requirements we talked about, and caching data, right?
Right.
And by caching, we mean the system storing the intermediate answers or the pathways of frequent queries, so it doesn't have to just burn computational power recalculating the exact same answer the next time someone asks it.
Exactly. And they also have to design fallback logic, in case the senior expert model fails or hallucinates.
Which is going to happen.
Right. And that fallback logic is critical. If a deep reasoning model gets stuck in a loop, the orchestration layer needs to recognize that failure, sever the connection, and reroute the prompt to a secondary system.
Without the user ever knowing.
Without you ever seeing an error message, yeah.
I have to push back on this a little bit, though.
Okay, go for it.
If the system is constantly shape-shifting behind the scenes, like switching between different models, different tiers, different fallback protocols, does an evaluation become an absolute nightmare?
Oh, it's a huge challenge.
Because when a software engineer tests a traditional deterministic system, like, say, a calculator app, they know exactly what code is executing. You put in 2 plus 2, a specific line of code guarantees a 4.
Right.
But with this probabilistic orchestration, the underlying engine doing the work could literally change from millisecond to millisecond. How do engineers, even QA, test a system that relies on probability rather than hard-coded rules?
I mean, you hit the nail on the head. The evaluation of probabilistic systems is the single biggest bottleneck in AI engineering right now. Oh, yeah. You cannot test an orchestration layer the way you test traditional software. You have to ensure that the intern model and the CEO model share the exact same foundational alignment, the same tone, the same factual grounding, even though their actual cognitive depth is entirely different.
So they don't contradict each other.
Exactly. If the user asks a question and the router sends it to the lightweight model, it cannot give a contradictory answer to what the heavy model would have said.
So how are they actually solving that consistency problem? Because that sounds like a mess.
By moving toward hybrid architectures, it is no longer just about generating text based on a model's internal pre-trained memory. Engineers are building systems that strictly separate the retrieval of facts from the actual reasoning over those facts.
Okay, so separating the knowledge from the thinking.
That's a great way to put it. Before any model generates a response, the orchestration layer queries an external, highly vetted database to pull the relevant facts. The models, whether it's the intern or the CEO tier, they are forced to use only that retrieved data as their source material. So by standardizing the facts that get fed into the models, you enforce a really high level of consistency across all the different tiers.
Which actually brings up a really fascinating secondary problem. If these systems are dynamically routing tasks and reasoning across complex multi-step workflows, they can't just forget everything the second you close the browser window.
No, they can't.
They need memory. Up until now, these models have been fundamentally stateless, meaning they essentially have amnesia every single time you hit refresh.
Right, and the source actually refers to this shift as the end of stateless AI. Gopanapalli highlights the emergence of what he calls the LLM wiki.
The LLM wiki.
Yeah, these persistent knowledge systems. AI is evolving to store, update, and retrieve knowledge over time, essentially migrating from a transactional tool to a persistent state.
So what does this actually mean for the average company out there? I mean, in theory, are we finally moving past those totally dead, static corporate internet pages that literally nobody ever updates?
God, I hope so.
To like a living AI system that actually learns the specific quirks, the context, and the actual history of a business over time.
That is exactly the vision for long-term enterprise knowledge management. Imagine an enterprise AI that is basically present in every meeting and Slack channel.
Okay.
It remembers the strategic decisions your team made 6 months ago. It understands the historical context of a specific client relationship, including, all those weird nuances in pricing negotiations.
Right.
And it updates its own internal understanding automatically as new documents are generated.
Yeah.
Your enterprise workflow becomes vastly more efficient because the system just never needs to be briefed from scratch. It builds compounding context.
Look, I love the idea of an AI that finally understands why our marketing team hates a specific font.
Right. We all need that.
But let's be real. Corporate data is a complete mess. It is filled with outdated PDFs, contradictory policy memos, and half-finished strategy docs. If AI is constantly absorbing all of this and updating its persistent memory, aren't we just going to end up with a system that confidently enforces totally outdated rules?
That's the fear.
Like, if two employees tell the persistent memory system totally contradictory facts, how does it know who is actually right?
The messiness of unstructured corporate data is exactly why memory cannot rely on neural networks alone.
Okay.
Neural networks are, they're phenomenal at pattern matching and language generation, but they are terrible at strict version control. They tend to just blur concepts together.
Yeah, that makes sense.
So to solve that exact contradiction problem you just mentioned, engineers are basically combining neural networks with symbolic logic approaches.
Break down symbolic logic for me in this context, because that sounds intense.
It's actually not too bad. Think of symbolic logic as a highly structured, strict filing cabinet, often represented as a knowledge graph. It defines explicit, hard-coded relationships. Employee A reports to manager B. Document X supersedes document Y.
I see.
So when the AI encounters a new piece of information, the neural network part interprets the natural language, but then it translates that information into a strict rule and places it into the knowledge graph.
So if employee A suddenly says they report to manager C?
Exactly. The symbolic logic system flags a direct contradiction based on its explicit rules. It forces a resolution or it creates a version history. It basically allows engineers to roll back the AI's memory to a previous state if some flawed document corrupts its understanding.
Okay, so we have smart orchestration dynamically routing tasks to the right level of intelligence, and we have persistent memory holding all the context and history using these strict knowledge graphs.
Yes.
When you put those two architectural pillars together, the way we actually interact with and create content changes dramatically. The source notes focus heavily on unified multimodal systems becoming the default here.
Huge shift.
We're talking about things like ChatGPT's deep image generation integration and Anthropic's Claude design.
Because multimodal workflows are dissolving the barriers between different creative tasks.
Right.
Previously, you generate text in one application, then you generate images in a completely separate AI image generator, and then you'd have to manually import both of them into a layout program like InDesign or Figma just to arrange them.
Which, to be fair, is basically how software has functioned since the dawn of the desktop computer.
Pretty much.
You have specialized tools for specialized media, but this feels to me a lot like the evolution of photography.
Oh, that's a really interesting comparison.
Think about the mid-20th century. If you wanted a high-quality photograph, you needed highly specialized knowledge. You needed a physical darkroom. You had to understand the chemistry of the developer fluid.
The exposure times, the aperture settings.
Exactly. It was a deeply technical craft. But then the smartphone comes along, and suddenly all that complex chemistry and physics is orchestrated invisibly behind a single button. You just point and shoot. What we are seeing with AI-native interfaces is that exact same democratization, but applied to high-end graphic design, data analysis, and software creation.
The photography parallel perfectly captures the democratization aspect here. These multimodal systems basically enable complete non-experts to lead complex creative workflows.
Yeah.
As the source points out with Claude Design, users can now translate natural language directly into comprehensive layout systems, typography choices, and visual hierarchies.
You just described the intent.
Exactly. You just say, create a modern minimalist landing page for a new coffee brand, and the system executes the design. But from an engineering perspective, the sheer complexity of doing this lies in managing state.
Managing, so you mean like keeping track of where the user is in the actual process?
Exactly. When you are iterating on a design, the system has to hold an incredible amount of conflicting context simultaneously. You might generate the layout and then say, actually make the hero text bolder, change the lighting in the background image to golden hour, and swap the call to action button to a softer geometry.
That's a lot of different systems needing to talk to each other.
It is. The orchestration layer has to parse that natural language, route the text request to a typography model, route the image request to a diffusion model, and route the layout request to a coding model, all while ensuring none of the new changes break the previous work you already approved.
Wow. So it has to remember the history of your commands, apply them across entirely different mediums.
Text, visual, code.
Right, and reassemble it into a single output. I mean, if these platforms pull this off, and it really is looking like they are, it completely threatens the existence of traditional software companies.
Oh, the source predicts that standalone creative software will absolutely face obsolescence if it doesn't fundamentally integrate this kind of orchestration.
It has to adapt.
If the interface is completely redesigned around intent-driven AI interactions, the old way of manually operating a user interface with a mouse, keyboard shortcuts, and literally hundreds of drop-down menus,
It just becomes archaic.
completely archaic. AI-native interfaces are going to replace traditional software precisely because they remove the friction of moving between multiple discrete tools.
But okay, empowering non-experts and deploying these autonomous agents to execute work, that sounds incredible for individual productivity. But if I put myself in the shoes of a CEO or an operations director, it also sounds absolutely terrifying.
They should. Deploying agents into production introduces massive cascading operational risks if the governance isn't built right alongside the capability.
Because we're out of the sandbox.
We're moving way out of the sandbox phase of AI experimentation. These systems aren't just drafting emails anymore. They are actually executing tasks, reading production databases, and triggering live workflows.
And here's where the anxiety really kicks in. Executives have to be terrified of an autonomous agent hallucinating a massive business decision.
Oh, absolutely.
It's one thing if an AI hallucinates a weird shadow in an image generation, like who cares? But it's a completely different level of disaster. If an AI agent hallucinates consumer demand and automatically triggers a supply chain order for 10,000 units of the wrong inventory.
Or hallucinates a legal precedent and automatically sends out a flawed vendor contract.
Exactly. Isn't this why the source mentions that observability isn't just a niche tech feature anymore, but an entirely new major market category?
If we connect this to the bigger picture, this is the ultimate dilemma facing the C-suite right now.
Yeah.
Leadership is forced into this really high-level strategic trade-off, balancing the demand for rapid innovation against the absolute necessity of operational reliability.
Because everyone wants the gains.
Every CEO wants the massive productivity gains and the cost reductions that come with agentic systems, but they are dealing with the inherent uncertainty of probabilistic outputs.
Right.
These models deal in statistical likelihoods, not the absolute ironclad certainties of traditional code.
So how do you even manage a workforce of probabilistic agents? You can't just unleash them and hope for the best.
No, it demands entirely new governance and observability protocols. And observability in this context, it doesn't just mean logging an error after the system crashes.
Right, that's too late.
It means building dashboards that trace the exact logical pathway an AI agent took to arrive at a decision in real time. Engineers have to design specifically for error recovery.
Okay, so anticipating the failure.
When an agent inevitably makes a mistake or encounters some edge case it doesn't understand, the system needs built-in circuit breakers. It needs to catch the anomaly, halt the execution, flag a human supervisor, and recover the workflow without causing some cascading failure down the entire supply chain.
This means organizations really have to completely redesign their workflows around AI execution rather than just trying to, cram an AI chatbot into their legacy human-driven processes.
Yes.
And the source makes a really bold statement here. It says that going forward, corporate leaders will separate themselves through execution, discipline, and reliability, not just rapid experimentation.
The era of just throwing AI at a wall to see what sticks, just
Yeah.
to say your company has AI, is over.
The hype phase is done.
The competitive priority is no longer just getting access to the smartest frontier models. Everyone has access to those APIs now.
Right.
The priority is the ability to integrate and govern them effectively. If you could deploy an orchestration layer that routes tasks efficiently, maintains persistent enterprise memory securely, and enforces strict observability protocols to catch those hallucinations before they impact operations,
Then you win.
you win.
And if you delay because you're just paralyzed by the risk.
The source actually warns that the cost of inaction is ultimately fatal. If you delay building these governed systems, you will simply be forced to operate within the ecosystems and rules designed by your competitors who figured it out first.
Man. So the cost of inaction is higher than the cost of adoption, but the cost of reckless adoption is catastrophic. It's a tightrope.
It really is.
Well, let's take a step back and sort of recap the journey we've just been on. because we've covered a massive shift in how the modern enterprise is going to function.
A lot to digest.
Yeah. We started with the core realization that AI is no longer just an isolated assistant living inside your software. It is becoming the core operating system itself.
Right.
We explored how this is being driven by multi-tier orchestration, the whole CEO versus intern model routing, which dynamically balances computational speed and cost.
Hmm.
Then we looked at the rise of persistent memory, where hybrid architectures using symbolic logic are basically turning AI from a stateless tool with amnesia into an evolving, highly contextual corporate brain.
Exactly.
And we saw how those capabilities unlock multimodal systems that completely democratize creation, turning anyone who can speak natural language into a director of complex workflows. And finally, we arrived at the C-suite dilemma. The urgent need for strict governance, circuit breakers, and observability to manage the very real risks of autonomous agents executing this probabilistic work.
The central theme to walk away with here is that the fundamental bottleneck in tech is no longer raw AI capability. The bottleneck is integration, governance, and the willingness to basically redesign workflows from the ground up to treat AI as a reliable infrastructure layer.
It's all about the architecture now.
Organizations that successfully transition from treating AI as a novelty to treating it as a governed execution engine, they are the ones that will define this next decade of business.
It's a profound transition. And think about what this means for your own daily workflow. We are rapidly moving from a world where humans do the manual executing and machines do the static storing to a world where machines do the executing and humans do the supervising. But that actually leaves me with one final lingering thought based on that specific idea of humans becoming supervisors.
Okay, what is it?
Well, if AI native systems replace traditional software, and if these intelligent agents are the ones doing all the foundational junior level execution work,
The drafting, the coding.
right, the data entry, the basic design, how will the next generation of workers ever learn the skills required to actually be a good supervisor?
Wow.
Because historically, you learn what excellent work looks like by grinding through the mediocre work yourself. You build an intuition for the craft by doing the grunt work. So if the AI orchestration layer takes all the grunt work away, how do we build the necessary human intuition to govern and correct these systems when they inevitably fail?
That is a fascinating question.
It's something we're all going to have to face. Think about that as you navigate your own workflows this week.